Bismillahirrahmanirrahim. We're going to start with scatter plot and Pearson correlation. Okay. Scatter plot and Pearson correlation. Kalau you all nak tahu, before you want to start the Pearson correlation, okay, you have to look at the scatter plot. Apa itu scatter plot? Is a graph that contain dot to determine exists linear relationship between variables to detect outliers. Okay, outlier I dah pernah ajar kan? Any value that is not belong to the group. And then to represent a relationships between two variables. Okay, dia macam ni. Scatter plot dia ada faksi facts. It has axis. Faksi dalam bahasa English is axis. Okay. It has x-axis. Yang mana x? Yang mana y? So usually this one is x. You learn any graph, the one that is horizontal is x and the one that is vertical is y. So scatter plot is in this graph. Okay, written somewhere. Wait, I use another color. Okay, it's somewhere here. It become a scatter because dia bersepah-sepah. Okay, madam? Ya, Allah. Okay, dia jadi scatter, it becomes scatter. Scatter lain. Scatter because, because the graph, the dot is dispersed along the graph. Dia di mana-mana je. So when you do a line here, to proceed with Pearson correlation, you must able to get the scatter the dot here along the line. Kalau dia bukan along the line, it means that there is no relationship lah between the two variables. So to make sure you can proceed with Pearson correlation, you have to do a scatter plot graph first. Okay, ini scatter plot graph. Okay. And then, okay, this is the type of scatter plot graph. Kita ada type perfect positive correlation. Perfect positive meaning that the scatter plot and the line, maksudnya you boleh buat direct garis macam ni Are you able to join, you able to join the dot here under one line. Okay. Perfect positive meaning that if variable y increase, variable x also increase. Okay. Kalau perfect negative, if variable y exists, variable x will be decreased, but under the one graph, one line. So you're able to get this one line and join all the plot. Okay, this is perfect negative. And then we have the third type is high degree of positive correlation. You're not able to join the plot. However, all the plot is near to the line, to the perfect line here. This means that you draw a perfect line from the axis here. Okay, and then the scatter plot is near to this line. Okay, macam ni. Maksudnya, it's meaning like banyak yang dekat. Banyak yang dekat dengan line. Macam ni dekat dengan line kan. Ni dekat dengan line. This is one near the line. This one near the line. Too many that near to line, even though it's not joined together, we call it high degree of positive correlation. Because when variable y exists, variable x also increase. Faham? The next one is high degree of negative. High degree of negative meaning that when variable y increase, variable x here is decrease. Okay, why? You can see here, when we do a straight line, okay, our plot, our dot here is near to the positive line. To the line, bukan positive line. Okay, it's near to the line macam gini, macam gini, macam gini, macam gini. When too many near to the line, tapi dia ada negative relationship, maksudnya seorang naik, seorang turun. So, it is high degree of correlation negative. Okay? So kita dah macam 4, we have learned 4, which is perfect positive, perfect negative, high degree of positive, high degree of negative. And then you will learn about, okay, this is low degree. Kalau low degree, dia punya differences is that you still have the straight line. But only that the differences, the plot here, this dot is not too near to the line. We still have a dot. The dot is grouped with each other. So dia duduk dekat-dekat. It is sit near to each other. However, not many is near to the line here. Maksudnya ada jauh-jauh lah. We have ada yang kat sini, kat sini, kat sini, kat sini. Okay. So this is low degree. Exist correlations, but it is low degree. Because even when variable y is high, variable x is also high. But dia tak sejajar, kata orang di dalam bahasa Melayu. Or in English we say that the differences, the increase and the decrease are not tally with each other. Macam tu lah lebih kurang. That's why the points here is quite far from each other compared to the high degree tadi. Okay, nampak high degree dia dekat-dekat. Low degree dia jauh-jauh sikit. Okay. Sometimes in low degree there exist outliers. Outliers meaning that the value is not belong to the group. Macam ni dekat X ni, the one I show you is outlier lah. Because it's far from each other. For negative pun sama juga. We have the line here, but the dot is not too near to the graph, to the line graph. So this is what we call low degree of correlation negative. It means that there exist relationships tapi dia low. Okay. What about no correlation? When you do scatter plot, you nampak macam gini. Macam gini. Like this. Like this. Like this, like this. Like this, like this. It's meaning that no correlation. So when no correlation, what you do? You do nothing lah. It means that there is no correlation. So no need to do Pearson correlation. Because even you do Pearson correlation, this does not fulfill the requirement to do Pearson correlation. Because for assumption testing Pearson correlation, it is need that the relationship between two variables must be linear and homogeneous. Ni, homodicity ni. Meaning that the one variable should be around the same value with other variable. So kalau you found out like this, it means that there is no correlation. So the step is simple. You go to graph, legacy dialog, scatter dot, and choose simple scatter. Okay, let me show you here. So the one that I've give you in the data set, the data set I give you lah. The title scatter and Pearson is regarding the length of track of a runner. Okay, this runner want to find out if the length of the track will affect his time taken to finish the race. Okay, so here in CM, he has this kind of value and the time is in second. How many seconds is need to finish this length of track lah, MKCM? This is in meter kot. Okay. So, you go to graph, you go to legacy dialog, click scatter dot, choose simple scatter, and then click define. Okay. The y-axis is the dependent variable. Okay. X-axis is your independent and y is the dependent variable. So for this case, the one that is dependent is your time taken, because the dependent, the time is depend on how long you can finish the race. Okay, so the length of track will become your independent. Okay. Title ni suka hati lah, kalau nak tajuk boleh. You boleh place like graph length GTH against time. Okay, ni title. The title will come out at above lah. Option. You don't have to put the option here. Doesn't need. Okay. Then just click continue. Okay. So this is your graph. Jadi frap pula. Ni gabungan frappuccino plus graph. So dia jadi frap. Okay. So if you look here. Okay. This is your graph. So what kind of graph is this? It's not straight line lah. Padam. Let's see the straight line ke tak. So this is my straight line. Okay. Straight line doesn't mean that you have to do the straight line from the O axis tau. This is O axis. Okay. Ni O axis. So doesn't mean that you have to do the straight line from here. Okay. A straight line can be drawn from joining the plot that is more than 3. You can join together. Okay, for example, macam ni kita ada 3 kan, 3 or more kan. So you will be able to join the graph here lah. So this is our straight line. So this is perfect positive ke, high degree positive ke, of course no, it has correlation kan. So I ada 2. Either perfect positive, high positive or low degree positive. Because kenapa I cakap positive? Because when when length increase, the time taken here also increase. So this is what we call positive correlation. Tapi dia perfect ke, low degree ke, high degree. Kalau tak dapat 3 ni but still near, we call it high positive. Kalau tak dapat langsung and dia jauh-jauh sikit, sini tapi dekat maksudnya along the line tapi jauh-jauh, kat sini. This is what we call low degree of positive lah. Kalau dia sepah, the one that scatter the most, dia akan jadi no correlation. So for this case, we have a perfect positive.
Please consider this high degree positive is not perfect positive because all the dots not all dots are connected to the line. It's a perfect positive when the dot is connected to the line. Okay.
So for scatter plot, bila you dah dapat scatter plot, you dah have scatter plot, you're going to look at the assumption testing. Okay. Before you proceed with Pearson, you must follow these 5 rules. First, related pair. Maksudnya score X and score Y must come from the same participant. You want to find out the time taken berlari dengan panjang track. So mesti orang yang sama yang berlari tu. You record the same person that run along that track. Bukannya you buat, okay, kau lari dekat track ni and then si A ni lari. Tapi you record masa si B, lepas tu you nak cari correlation antara jarak yang A lalu dengan masa A lari. Jarak yang A lalu dengan masa yang B lari. You ask the different person A to run, but you record time taken for B. Then you find correlation. It doesn't work that way, man. No. It work when the same participants. You record the same participants. And then the scale of measurement mesti interval or ratio. Okay, bukan maksudnya it doesn't mean that you have to get in Likert scales or ranking low, medium, high. No, not really. You can also get a scale like the height or maybe the weight, age, CPJ. As long as it's scales or it's intervals or it's a ratio, we able to do Pearson correlation. As long as the two variable is in continuous variable. Okay, highlight continuous variable bermaksud ni. This is the meaning of continuous variables. You must take note here. Nanti kan tanya lagi, apa continuous, apa continuous? Continuous variable is that the unlimited number of value between lowest the highest. Not related to grouping. Race bukan continuous variable, dek. Faculty bukan continuous variable. Faculty is not continuous variable. Race is not continuous variables. What else? Religion is not continuous variable. Class is not the continuous variable. Any value that doesn't have the lowest and the highest in the variables, it's not a continuous variable. So you cannot proceed with Pearson correlation. So what kind of continuous variable? Age can be continuous variable. For example, you have low age sampai high age. Umur 10 sampai 60. So that's age you can use as component in Pearson correlation. What else? Alhamdulillah. We have age, CGPA. We have kalau Likert scale, we have like suka tak suka tu kan. Usually teaching style. Teaching style you have suka tak suka tu, you can do Likert scale. Pearson, teaching style and etc. Factors that you have like a scale or maybe interval or ratio, you can use Pearson correlation. Tak ada masalah. And then the third one, normality. The score is normally distributed. Normally distributed meaning that there is no outliers. Data tu value dia semua sama. Macam ni kita panggil this is normal, normally distributed lah ni. Okay? Because the data tu the value is near to each other. And then linear. Ni linear. Ini maksud dia linear. Line ni, you able to get this linear straight line. Tak kisahlah dia segini ke, dia segini ke, segini ke. As long dia bukan macam ni, as long it's not like the blue one here. Wait, I did it first. The straight line must be either this one or this one or this one. As long it's not like this or like this or like this. Boleh lagi ni, there is still relationships. Not like this, not like this. So if as long as the red one, you can still do Pearson correlation. It means there is a linear relationship between two variable. Macam ni pun boleh. Like this also can. Like this also can. Also the one that is in red one also can. But tapi kalau yang macam biru ni, the one that in blue, it means that you cannot use Pearson correlation. Yang macam grewel-grewel ni lagi lah. You cannot do Pearson correlation like this. So it must be linear. And homoscedasticity. It means that the variables in the score should be around the same value of other variables. Okay. And the concern with the score must be uniform around regression line. Ni regression line. This one is regression line. Okay. The score must be around here. Tak boleh kat sini. Cannot be in here, in here, in here, in here, in here. As long as along the regression, it means it's in the grouping value. So it means that this is homogeneous. And then the value is roughly same value with each other. Maksudnya dekat-dekat lah. For example, if you look at the SPSS here, okay, this is your data kan? You look here, dekat length track. Okay, here kan kalau you nampak, dia 35, 24, 45, value dia lebih kurang sama. You tak ada pun nampak 30.99 or jadi satu pula. Or you dapat tiba 100 ke 1000. So the value near to each other. This is what we mean by homogeneous. So sekarang ni the data kita tengok we compare one by one with the one that we have here. Related pair. Okay. Length track dengan time taken ni daripada same participant. Okay, pass. The data should be interval, ratio ataupun scale. Okay, dua-dua scale. No problem. The data is normally distributed. You tengoklah graph, dia kurang dekat-dekat je. So it's near to each other. So we assume ni normally distribute lah. And then the relationship between variable must be linear. Ni, the one that we draw graph here. Dapat straight line. Linear tu. And then, the homogeneous. The value is around the same value with others and uniform around the regression line. Ni regression line, we're able to draw straight line. And then we see that the data, the value dekat-dekat dengan graph tu. So dia maksudnya is near to regression line lah tu. Oh, dia guna persamaan ni. You're able to do straight line using this what we call the if chart editor. Okay, it doesn't have to be. Tapi the thing is that you must know the equation lah of the straight line. If y equal to 0, then dia jadi macam ni. Boleh delete. So the line here, if you want to do line in here, you must do the what we call equations. You must know the equation to get this kind of line lah. Okay, so kalau tak nak nyusah diri, just copy paste. We must know what is Pearson correlation. Pearson correlation is a measure correlation yang kita measure strength and direction of a linear relationships between two continuous variable. Maksudnya kita nak tengok kekuatan dan juga arah perhubungan antara sesuatu variable. We want to look the direction where this love go. and the strength of the love between these two people. Dalam case itu variable. Okay, we want to know where the relationship go and what is the strength of the variables. And then we want to find the relationship between the two variables. So itu tujuan Pearson Correlation. And then dalam Pearson Correlation, we have two type of significance. Dia ada H1, dia ada HO. Dia ada one tail and two tail. Kalau one tail, maksudnya dia ada direction. Okay, pernah ingat tak? Do you remember? I pernah cerita kat you pasal Azwan Ali punya case. Okay, ingat lah Majemah nampak Azwan Ali. So, how come we say is two type ataupun one type of test? One tail or two tail, sorry. Kalau one tail dia ada direction. For example, Mak Jemah nampak Azwan Ali keluar dengan Remy Ishak. So you have direction, you know that person is Remy Ishak, you know he come out, the divide AA and Remy Ishak come out together. So itu directional. You have the person, you have the details about the relationships. Positif ke, negatif ke, you know the direction. But for two tail dia berbeza. Okay, one tail and two tail the effect pada hash alternatif je. It does not affect HO. HO for one tail and two tail sama je, nampak? HO dia sama. H1 ni beza. Kalau H1, it has direction. You tahu. Azwan Ali keluar dengan Remy Ishak berdua. So that is direction. There is a positive ataupun negative relationship of that variable. Kalau non-directional, dia tak ada arah. You only know there is relationship but you don't know positif ke, negatif ke, strong ke, weak ke, you don't know. So, you only know there is relationship. Contoh macam kalau you membawa, you cakap, I saw Azwan Ali go out with someone. Tak tahu someone tu jantan ke, betina ke, maknya ke, bunde ke, you don't know. But you just know that Azwan Ali come out with someone. That is non-directional. Kalau Azwan Ali keluar dengan Remy Ishak, that is directional. When the relationship has positive or negative, strong or weak, that is directional. One tail. When you say there is relationships without knowing the strength or the positive or negative relationships, you don't know that, then it is non-directional. We call it two tests lah. So, how we do it? Okay. You go here, go to analyze. You go to analyze, you go to correlate. Analyze, correlate, bivrate. Analyze, correlate, bivrate. Click here. Okay, after you enter the variable here, you choose Pearson. Kenapa nak pilih Pearson? Dah you want to do Pearson correlation. Kalau you do candle correlation, you click candle. Kalau you do Spearman, you click Spearman. In this case, you use Pearson. So click Pearson. And then the test of significance here. Okay, so the test of significance ni nombor 3 ni. Here is number 3. So look here number 3. By default dia memang akan bagi you two tail. It means that there is no direction. Tapi kalau you memang dah ada assumption from your previous study, you dah ada experience, you memang tahu bahawa ini kena dapat negatif atau kena dapat positif. So, you do one tail. So, in my case, okay, since I don't know yet what is the relationship between these two, I choose two tail. Tapi kalau you tahu relationship between these two, then you choose one tail lah. And flag significant. You tick flag significant je kan? It means that kalau flag significant, ni yang nombor 4 ni, for here, so you look here. Flag significant meaning that dia akan tunjukkan 2 asterisk dekat you punya result nanti. So meaning it will shows that your alpha value is 0.05 or 0.01 lah. Salah satu. Since our case we always stick to 0.05 because our confidence interval adalah 95%. So we stick to 0.05 only. Okay. So tak payah kacau apa. Tak payah klik option. Okay. Bootstrap pun tak payah. You just leave here. Correlation semua ni tak payah kacau. Pearson, two-tail, flag significant, okay. So this is your result. Ambil table ni, you control C, control V. So this is your table. First we going to look at the SIG one tail. Okay. Kalau kita dapat 0.05 lebih kecil, kita akan reject null hypothesis. Okay. In this case, since kita guna two tail, okay, so dia dah cakap asterisk kita adalah 0.01. Okay, tadi dia kata 0.05 kan? So dia antara dua, either 0.01 or 0.05. Since you tengok ni, asterisk ni dimension berapa? Kalau dekat asterisk ni dimension 0.01, dekat SIG here, ni. Kalau dekat ni, asterisk ni asterisk okay. Here dimension 0.01 is mean that here you have to look at 0.01 bukan 0.05. Okay. Kalau dekat here dimension 0.05, so you look compare with alpha value 0.05 lah. So dalam case ni we compare the alpha value 0.01. So kalau dia lebih besar daripada 0.01, we accept null hypothesis. So our hypothesis tadi, kita guna two-tail kan? So here is our hypothesis. There is no significant relationship between length of track and time taken to finish. And our hash null, kita dapat there is significant relationship between length of track and time taken to finish. Okay, so this is nombor 2 ialah Pearson Correlation. Okay, Pearson Correlation, tak kena guna. Okay. Nombor 2. Pearson Correlation, lambang dia adalah R kecil. Okay. So, in this case, the Pearson Correlation, you kena tengok table ni. The value adalah daripada 0 ke 1 tau. 0 ke 1. Negatif 1 ke positif 1. The value is from negative 1 to positive 1. So you have to tengok the value. So tujuan dia adalah it for the strength of the relationship. Okay, dalam case you tadi, you got significant. Okay, nampak ni. You got 0.00 which is smaller, kita reject null hypothesis. Meaning that there is significant relationship between length of track dengan time taken. Okay. So you look at the Pearson Correlation. RU 0.955. So you tengok table. 0.955 maksudnya adalah near to perfect positive. So maksudnya kita akan cakap the relationships tu ada almost perfect positive relationships between length track dengan time taken to finish with N10. Okay, I show you how to explain how to do report. First, you kena tengok the one that I label as 1. I label 1 here SIG 0.00. Okay, so you cakap null hypothesis is rejected. There exists
There exists significant relationship between length of track and time taken to finish with very high positive atau strong relationships, where R is the Pearson correlation equal to 0.985 and P the significant value is 0.00 and M total of participant is 10. Okay, kalau tiada correlations, okay, when there is no correlation meaning that you get significant value above the ask-the-seek value tu, kalau kata kat situ 0.01, 0.01 lah. Kalau kata 0.05, 0.05 lah. So if you get that, so the conclusion is like this. Null hypothesis is accepted. There is no significant relationships between length of track and time taken to finish. Okay? So, kan, kalau you tengok dekat the one that I teach you before, okay, I said kalau nominal order boleh kan? No, actually we only do Pearson for scales yang ada low and high minimum low and high value lah. Usually we have minimum and maximum values. So for example, something overall score and percent mark and value here. Okay. For something class and SM grade, we did not do Pearson correlation. SM grade is in ordinal where it is 1, 2, 3, 4. We have to use the real mark, where we call a raw mark. Okay, to do Pearson correlation. Okay, that's all.
okay, in your group, I have posted you for test homogeneity variance. This kind of pictures sekejap So, this picture. Okay, for this picture, it is different from what ANOVA that I've shown you before. The ANOVA that I've shown you in your class is this one. Okay, this kind of ANOVA table. Sekejap Okay. Okay, as you can see from the screens, I show you the test of homogeneity variance for your syllabus from my SPSS lah. My test of homogeneity is this one. Ni. This is my Levin homogeneity. But yours is this one. So where you want to refer is the first row here. You will look at the based on mean here. Actually, I forward the answer, but I think gambar je yang terforward. So for this class, for this the first lane based on mean here must be larger than 0.05 for you to proceed with ANOVA table. If it's smaller than 0.005, so you cannot proceed with ANOVA table, okay? And then for the second question that I get is regarding okay, for ANOVA, it is a group for a group, like for one of the variable must be grouping tau. Grouping meaning that the variable of ANOVA must be more than 3 groups. If you only have 2 groups, like female, male, or you only have 2 faculty, for example, FSKPM and FK only, the best way is to use independent t-test instead of using ANOVA. ANOVA is for grouping that is more than 3. You want to compare the differences between more than 3 groups. And the second one is that for ANOVA, you only look for mean difference. So it is okay if there is no mean difference. Tak ada masalah. Because you want to look if either exist differences or not. That's all. If belong the society, there is no differences, meaning that between the group, they have same level of something lah, the one that you test. So you don't have to care if it is not difference or it is different. Nothing wrong with that. Okay? And then the third one is that regarding your apa lagi satu ni? Okay, variables that you want to choose. The factors. You said that you have factors, kan? The factor must, when you do end the test, you have factor tu have a lot of questions, kan? You ada banyak soalan bawah tu. You only compute it become one variable, one new variables. For example, you have 10 questions that represent the factor of eating style. So compute that 10 question to become one variable which is eating style factors. Okay, itu je. You doesn't have to do one question and you relate with age, satu soalan. No, dia tu membazir. And then for the fourth one, yang keempat adalah one sample t-test is not independent t-test. Okay, one sample t-test tu yang one mean that I teach you, yang is not in your syllabus, but I have said to you before what is one sample t-test. But for independent t-test, okay, independent is the one that I have teach you where we want to do a variable between two variables. We want to find the differences in mean. In one t-test you won't find differences. Okay, apa lagi? And then apa lagi soalan ni? Okay, horizontal mean yang I tunjuk hari tu where you compute all the questions. Okay. And then what else? Okay, if your ANOVA stop here, then just explain until ANOVA only. Like here you got 0.629. So you stop till here. Okay, doesn't have to explain more details. Okay.